Okay, so this problem, the question is to find the derivative. And this is a prime example of a function that you can only get the derivative of it by using logarithmic differentiation, because you have a function raised to another function and you don't have a rule for that. So remember your steps for using logarithmic differentiation. The first is to get the log of both sides. Okay, so get the log of the left side and the log of the right side. So it's okay that there's another log there. We'll just leave it alone. All right, so then on the left side we'll get log of f of x is equal to, now this natural log we're going to bring it down using the laws of logarithms. So we're going to have natural log of x times natural log of x. Okay, and this actually you can simplify into, now you have to be a little careful here. You can simplify this into natural log of x, the entire thing squared, which is not the same as natural log of x squared. So this is not the same thing, because here you can bring the the 2 out in front, but here you can't. So it is different, so just keep that in mind. Okay, now normally you don't simplify, but in this case it made sense to. Okay, then the second step is to get the derivative of both sides. Okay, so we get the derivative of the left side, derivative of the right side, and on the derivative of the left side, remember you get 1 over, so the derivative of natural log is 1 over the inside, which is f of x, times the derivative of the inside, which we symbolize by f prime of x. Now this is equal to, now the derivative of this guy, we have to use the chain rule here because we have an outside function which is a squared. So the chain rule tells me, okay, bring the 2 out in front, leave the inside alone, subtract 1, so this is going to be raised to the 1, times the derivative of the inside, the derivative of this guy, which is 1 over x. Okay, and then the last step is to simply multiply both sides by f of x to get rid of it. So in this case what I'm going to get is that f prime of x is equal to 2 natural log of x over x times f of x, which is the original function, which was x raised to the natural log of x. And that's it. That's the derivative. Okay, so let's say you have another function here, and we're looking for, again, the derivative. Now, doing this guy directly would be a terrible idea, because notice that what would happen is you would have to use the chain rule first, because you have the whole thing as being raised to the, well, it's cube rooted, or raised to the 1/3. And then inside, though, you would have to use a quotient rule. Inside the quotient rule, you would have to do the product rule, and inside the product rule, you would have to do all these chain rules. So this would be a huge mess. A much better idea is to use logarithmic differentiation, and when you do that, what you can do is you can break up this massive monstrosity into several different chunks, and that gives you a more manageable function. So the left side is just going to be natural log of f of x, and this is going to equal to, now this guy right here, this cube root, instead of being cube root, Remember, that's the same as being raised, the whole thing raised to the 1/3. So I changed that one to the 1/3 because it makes it easier. Now, to break this guy up, remember, the exponents are going to be out in front, all of these exponents. And then the guys on the numerator are going to end up being positive, and the guys on the denominator are going to end up being negative from the laws of logarithms. So we're going to use all of them at the same time. So on the very, very outside, I'm going to have 1/3 times, and then inside, I'm going to have, so here, the exponents, all of these guys, are going to come out in front. So the first one's going to be x times natural log of 4 plus, bring down the 5, natural log of 3e to the x plus 4x. Now these guys on the denominator are going to end up being negative, so minus 3 natural log of x. And then this one also on the denominator is going to end up being negative as well. So minus 2 natural log of, here you have to be careful, it's natural log of this whole thing. So natural log of x minus 5x. Okay, and then we can do our usual, get the derivative of left side and the right side. And so on the left side, I'm going to get 1 over f of x times f prime of x. And then on the right side, why don't I, when I get the derivative, I'm also going to distribute this 1/3 onto everything, just to make it a little nicer. So here, natural log of 4 is a constant, so I'm just going to leave natural log of 4 there over 3, that's the 1/3 that I distributed, and then the derivative of x is just 1, so times the number 1, which you can just not write if you want to. It's actually better if we don't write it. Okay, plus, and I'm going to leave the 5 over the 3. Now the derivative of each one of these little logs is log of, so it's going to be 1 over the inside, so 1 over 3e to the x plus 4x times the derivative of that inside. So the derivative of 3e to the x plus 4x is 3e to the x plus 4 minus, and then 3, the derivative of natural log of x is 1 over x. And then don't forget over 3 as well. So you can reduce those if you want. And then minus 2 over 3. Now here, got to be a little careful. This is natural log of this guy. So it's 1 over the inside. So 1 over natural log of x minus 5x times the derivative of the inside, which is 1 over x minus 5. And then last but not least, you get rid of the f of x by multiplying both the left side and the right side by that original function f of x. And f of x is this guy right here. So I'll spare you having to write that down. But it's this entire thing times the original function, which is right there. So we want to find the equation of the tangent line for this function at 1, 1. So remember, the very first step is to find the slope, which means find the derivative at the point, which in this case is 1. So let's start off by finding the derivative. F prime of x is equal to, now the derivative of natural log of this stuff is 1 over the inside by the chain rule, x e to the x squared, times the derivative of the inside. Now when I get into the inside, I have to use the product rule. And so then what I have is the derivative of the first, which is 1, times the second, leave it alone, plus the first, leave it alone, times the derivative of the second. Now the derivative of this guy, I have to use a chain rule as well. So that's going to be itself e to the x squared times the derivative of its inside, which is 2x. Okay, and then that's the derivative. So now the slope m is the derivative at 1. So if I plug in 1, I'm going to get 1 over, this is 1 times e to the 1 squared, so that's just 1, and then times, whoa, wrong color there, times e to the 1 again, plus 1 times 2, so this is going to be 2 times e to the 1. So this is 2e plus e is 3e, and then over e. So this is equal to 3. So 3, the number 3 is the slope. So now the second step is to find the y-intercept, and that's not too difficult. Remember, you always do this the same way. You have y equals to mx plus b. You plug in your slope, which is 3. You plug in your x value, which is 1. And then you plug in your y value, which in this case it's given. It's also equal to 1. But if it wasn't given, you would simply plug in the x value into the original function and you would get the y value that way. So if you do that, you would get that b is equal to 1 minus 3, so negative 2. So these two put together give you your tangent line, which is y equals to 3, the slope, x, and then minus 2. And that's it.